What's going on, everyone? In today's lesson, we'll be going over a slightly different equation for linear functions and go over why, well, first of all, they're exactly the same and they kind of exhibit the same behavior, but they're just written a little bit differently. All right, so let's go ahead and jump right into it. All right, so when we're dealing with equations of straight lines, perhaps these may or may not look familiar. Most likely this one is the y equals mx plus c or y equals mx plus b, and it really is just y equals the slope times the x-coordinate plus whatever our y-intercept happens to be. And what we're going to go over today is going to be called the point gradient or the point slope form, which is this one right over here. And the reason being is that because we have the point, which in this case is going to be x1 and y1, but don't forget that negative sign, and we also have the slope. And so we quite literally have a point and a slope. Point slope form. Easy way to remember. And let's take a look at what that is, but first just a little refresher. If we're looking at the equation of a horizontal line, notice that if we're going completely across, that is going to pass our vertical line test. It is only going to intersect this graph at one point. And if you notice, everything here is going to have, here I'll have 1, 2, here I'll have 3, 2. We're all going to have the same y coordinate of 2, and we'll say that y is equal to 2. On the other hand, if we have a vertical line, that's of course going to fail our vertical line test because it's technically going to intersect this at an infinite number of points. And you'll notice that kind of in the other example where everything had the same y coordinate, this one everything's going to have the same x coordinate. We would say here that x is equal to 3. All right. So let's go ahead and take a look at an example. So if we have an equation of the line and it has a gradient of 3, it's going to pass to the point A, which is 1, 7. So we're going to use the point slope form here to see how this works. So we want to find the equation of this line. Well, what I'm going to do is I'm going to have y minus y1. In this case, my y1 is just 7. So write my y equals, so I have y minus 7 equals my slope, which is going to be 3. And then I'll have x minus my x1, which in this case is just 1. And there we have it. So that is how I'm going to write that, problem where I'm given a point and a slope in point slope form. It's that easy. And one thing to notice is that this is kind of written as minus 1. This is written as minus 7, kind of the opposite polarity as our coordinate. Now, if I wanted to rewrite this in our standard y equals mx plus c form, this actually wouldn't be too difficult. And you can actually do it directly from this equation because all I would have to do is distribute that 3. So I'd have 3x minus 3. And then I would just move that 7 over. I would have y is equal to 3x minus 3 plus 7. That's going to give me y is equal to 3x plus 4. So again, these two equations right here are referring to the exact same line. They will give you the exact same input and output depending on what you put into the function. So now let's focus on b right here. Let's find an equation of the line that passes through a and b, 1, 3, and 2, 5. Let's take a look at how to do that. Remember, slope is simply rise over run, or it's the difference in our y coordinates divided by the difference in our x coordinates. We have to make sure that these are matching, that they're referring to the exact same coordinate. All right, so if I'm going to go ahead and do that, I know that let's call y2 5. Let's call y1 3. Let's call x2 2 and x1 1. Then I would just simplify. I would have 5 minus 3. That's going to give me 2. 2 minus 1 is 1. So my overall slope is 2. Okay, so that's going to be the value of m. Now I'm going to go ahead and erase this just to clear up some space. So now that I know that my slope is 2, let's figure out how we can actually get this in point slope form. So I'll go ahead and I'll use this point right here, a, 1, 3. So if I just want to write this out, I would have y minus y1. In this case, that's going to be 3. My y coordinate is equal to m times 2. Then I have x minus x1, which in this case is just 1. So now I can leave it here and have it be in point slope form, but I'm going to take it one step further and get back to this y equals mx plus c, just so you can really see the link between the two. In that case, I would do the exact same thing that I did before. I'm going to distribute that 2, and then I'll get y is equal to 2x plus 1, just like that. So again, that's how you can go back and forth between the two. And if I wanted to go ahead and graph this, I know that my y-intercept is 1 because of this information right here. And I know that my slope is 2. That means I'm going to rise 2 points and go over 1. Put that right here. And there we have it. Just connect those lines. Fortunately, with Notability, it's quite easy to do. And there you have it. Now I have a slope of 2, and I have this function, y minus 3, 2 times x minus 1 in point slope form, or y equals 2x plus 1 in that traditional y equals mx plus c. All right, let's take a look at another example. Okay, so I'm asked to draw the line 3x plus y plus 3 is equal to 0. The easiest way for me to draw this and graph this is in that y equals mx plus c form. Okay, so if I wanted to go ahead and do that, all I have to do is rearrange this equation just a little bit. So I want y all by itself. If you notice that I would have a 0 here, that means I'd move the 3 over and I'd move the 3x over. So I would have negative 3x minus 3. And just by using that little trick, I can now graph this one really easily because I know that my y-intercept is going to be negative 3. Put that right there. And my slope is going to be negative 3, meaning I'm going to move down negative 1, negative 2, negative 3, and over positive 1 right there. And just like that, I can now... And there you have it. That's how you can go from something that looks a little bit unfamiliar into something that looks quite familiar, hopefully, and graph it really easily. So that y equals mx plus b form is super useful when we're graphing, but it's this other one, this point slope form, is actually really easy to write out given the context of the problem. So again, it kind of just depends on what the question's asking you for, but they're all going to relate to the same exact thing. So I hope that helps. I hope that you now see the connection between point slope form and point intercept form, which is that y equals mx plus c form. And you can kind of see how one is more beneficial for graphing and the other one does have its use case just depending on what the problem is asking. Okay, so in our next video, we'll go over a few more example problems and get a deeper look into what these actually look like with different problems. All right, see you in the next one.